Hey guys, today we're going to solve LeetCode number 763, partition labels. So this problem is kind of straightforward. We're given a large string and we need to return the lengths of the partitions, and we need to make the partitions so that every letter is only in one of the partitions. So this, for example, the A is only in these partitions, it's not found in these two. Same goes for B and C. D is only found here, and so on. So the first thing that I want you to notice is that there is no way to do this problem in any lower than O of n memory, because the output is potentially as long as the string. So if we had the string that is like A, B, C, D, E, F, G, and so on, then you'd have to output 1, 1, 1, 1 repeated n times, where n is the length of the string. So just to do that, you would take O of n memory. Okay, so might as well make a good use of that O of n memory, So we're going to store the maximum index at which we find one letter. So whenever we go through that letter, we loop through the string and we go through the letter A, for example, here, we know that the first partition is at most as short as this one. Now, if while going to the last index of A, we find another letter that is an even higher maximum index, then we'd have to extend that partition even further. So for example, let's say that while going to this maximum index here, we found like the D character, then we'd have to go up to the maximum index of the D character. Okay, so that's exactly what we are going to do. So we're going to store in a map the maximum index at which a certain character is found, and we're also going to store our result, which later on we're going to have to return. And now we just need to update there is a max index found and this result. So we go through all of the indices of our string and we update we take the current character of the string and we update its max index at which it's found to the current index. Okay, so now we have the max index found map correctly set up, and now we can start updating our result. So what we do is we store the current maximum index that we need to go to satisfy to have a valid partition, and initially we're going to set that to the maximum index at which the first character of the string is found. So we take the first character of the string and we say, okay, initially we need to go to the max index at which we find the first character, and this might as well could be as well the last index of the string. There's nothing forbidding that. So now we go and say the current length of the partition that we're making right now is 0, and then we're going to increment this in a for loop. So now we loop through all of the characters of the string, and for every iteration, well, first of all, now our partition is longer than before, so we increment it, and now we check if we need to update the current maximum that we need to go to. So we check the current character of the string that we're looping on, and we go to the max index found map and we check if the value in the map is greater than the current maximum that we need to go to, and if it is so, we update this variable. So this is the very common updating via the mathmax function. Okay, and now we check if if our I is actually equal to the current maximum that we need to go to. So if we are at the end of one partition, okay, then we can push the current length and reset the current length to 0, because we don't want the length of the previous partition to carry over to the next one. So yeah, that's the solution, and it's optimal because it goes through every character once, and obviously we can't do any better than that. And then the memory, as I told you, has a lower bound of O of n for the result variable. So yeah, this is optimal. So that's it for now, and bye.